Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel tanmoyChem. Today's topic of discussion is on MCQ. The question is in front of you. I request you please pause the video, try by yourself, and whatever your answer, please write in the comment box along with few words as explanation. Don't worry, after some time I'll explain. I think you have tried. Let's start. So what is the major product of this reaction? Means this is a carbonyl ester compound reaction with sodium borohydride in methanol and later on what? Acidic workup. Now if you look at this reaction, this is simply a reduction reaction, and sodium borohydride is actually a mild reducing agent where the 4 hydrogen atom attached with central boron tetrahedrally, where boron carries this formal negative charge and these hydrogens are delta negative, so they act as a hydride, they shift and they are actually responsible for this reducing character. This is the thing, and actually they are electron rich, so you can say they are nucleophile. So in this way this hydride will act as nucleophile, and methanol is actually solvent for sodium borohydride. Now sodium borohydride, remember, is actually a mild reducing agent. Mild means you can consider less powerful reducing agent. More powerful like lithium aluminum hydride, that's a different issue. So sodium borohydride, and if you look at, there are two types of carbonyl. One is this ketone carbonyl. So this has a name, remember, it is a ketocarbonyl, and this one is called ester carbonyl. Now ketocarbonyl is actually, I'll say, more electron rich. Why? Because you see here this carbon is directly attached to oxygen. Oxygen is more electronegative, so this is delta minus, this is delta plus. Some places you can see this canonical form. Okay, so these will take this bond pair O minus carbon plus. By the way, believe me student, if you draw such kind of resonance, the contribution of this charge canonical form in the overall electronic distribution of the molecule is very less. Fine. So it's so generally I can say this is delta positive, delta negative. Now if you compare this with another carbonyl, this one, this is called ester carbonyl, as I told. In this case, such kind of canonical form possible. So you can write O minus carbon plus, where oxygen is attached, but this canonical form is stabilized to some extent by the lone pair of adjacent oxygen molecule. So you can see another canonical form, this. Now in the second canonical form, all atoms are octet filled. So these all are octet filled. Here this carbon is 6 electron. This is also 6 electron. Okay, but here this is a 8 electron field or 8 electron structure or octet field. So this has a significant contribution. So what does it mean? This contribution means the carbonyl carbon is more electron deficient because it's carrying positive charge, whereas if you look at ester carbonyl, this is less electron deficient because of this cross conjugation by this OET or ester molecule I have shown here. Now consequently sodium borohydride will reduce the ketone only, ketone into secondary alcohol. So you can expect that, okay sir, the product will be, this is OH, obviously after workup, and this part CH2CO2ET will remain as it is. Now you may think, sir, why doesn't sodium borohydride reduces this ester? Because it's a mild reducing agent. At the beginning I told it is less reactive. It is not that much reactive to reduce the ester. By the way, if you take lithium aluminum hydride in this example instead of sodium borohydride, then both will be reduced. So here sodium borohydride fails to reduce the ester into the corresponding alcohol. So option will be only this reduce. So option A, I guess. Option B not possible as ester also reduced. Option C for decarboxylate, no, not even possible. If you look at option D, only ester reduced, not carbonyl, no, that also not possible because this ketocarbonyl is far more reactive or electrophilic compared to the ester carbonyl. So overall answer in this today's problem is option A. Now this is the end of today's discussion. I believe this video will be useful. Please write your opinion in the comment box. See you in my next video. Bye bye.